Hi, this is Tricky Hands, and this video is in response to a question that was asked on the Unity forums by a user named Shakaz. Here is the thread here, and I'm actually going to put the link into the package that I'll do for this. The question that was asked here was about interpolating camera positions or camera rotations between one rotation and another rotation through animations, so there was a nice curvature to the interpolation. I was talking about doing things like camera transforms.lookat and whatnot, and eventually posted this GIF where I'm using a BlendTree to interpolate between the two target rotations. That apparently is not a very common utilization of Mecanim. Most people use BlendTrees for things like blending between a walking animation and a running animation, those things. But doing more simplistic blends, it's not really used that much. So there's not a lot of reference material on it. Well, Shakas ran into some issues in doing these blends, and I said I was going to put together an entire package and a video and show how this whole technique could work. So I'm going to pop into Unity right now, and we're going to make this happen. So starting off with a brand new scene, the first thing that we need to do is start animating our camera. So I'm going to create an animator controller. I'm going to call this camera animator and drop that onto our main camera. Now that we have that animator, we can start animating. So with the camera selected, I'm going to hit Control-6, I believe it's Command-6 on Mac, and we can start creating our first animation. So I'll hit Create, and we're going to make our first animation, which is going to be the float animation, a 0 value for all of our rotation here, and we'll add that transform rotation property. So once we've added the property, Unity by default is going to add a keyframe at 0 and a keyframe at 1 second. We need to get rid of the 1 second. So we only want this single frame. So this is very, very simplistic interpolation between one frame and another frame of animation. We're done with our first animation. We don't need anything else here. And now I'm going to create another animation. This one's going to be for our dive. And following the same technique, we're going to do adding our rotation, delete the 1 second, get our single keyframe here. This time I'm going to change the x-axis rotation to 30 degrees. So you'll see we have that nice frustum rotation here in our camera preview. Our horizon line is just below the top of the camera's view frustum. So we're done with animating this thing. We can start working in our animator controller. So I'll open up our animator window, and you'll see we've got two states for our newly created animations, but we're going to get rid of those. We're going to do everything here with a BlendTree, so that means we need a float parameter to control that BlendTree. So we'll create that now, and I'm going to call this dive. We're going to use it all lowercase. Remember the case on that because we'll use it in the script. And now we're going to create a new state from a new BlendTree. Select that. I'm going to call this dive BlendTree just for clarity. And we'll open up the BlendTree. We have our empty BlendTree here that is controlled by our dive parameter. I'm going to add two motion fields. Our first one, which is going to be our 0 value of our parameter, is going to be the float. And our dive will be at the 1 value. So as we blend this parameter, the closer it gets to 1, the closer it'll be to that single frame 30-degree rotation on the x-axis for our main camera. And if we pop into play mode and then take a look at our animator, we can now actually do that interpolation directly from our BlendTree. So you'll see we're at 0 rotation here, and then if you look in the inspector, our x-axis is now at 30 degrees. So that nice smooth interpolation can happen between those two single frames of animation. that's it for our animator controller. The big heavy lifting is going to all be done through script. We're going to be using some coroutines or one coroutine to handle this, and doing some really interesting stuff with animation curves. So for that, I'm going to create a brand new C# script. I'm going to call this dive camera handler. Drop that onto our main camera, and I'll open that up in Visual Studio right now. So we've got this nice empty script. I'm not going to be using start for initialization of anything. We're either going to assign it in the inspector, or it's not going to be there. So the first thing that we're going to want here is I'm going to set up all of our public and private fields. The first thing that we need is going to be a reference to that animator. So we'll take our cam animator, and then we're going to set up some duration values and some animation curves that we'll use for this animation. So we're going to do public float, and this is going to be our enter dive duration. So you'll be able to customize how long you want it to take to get from 0 value to a full dive. And we're going to do a public animation curve. We're going to call this enter dive curve. And that's going to serve just like how you set up your curves inside the animator window. You'll be able to get that same nice curvature between 0 and 1 on the animation curve in the inspector. Once you actually see it, it's going to make a lot more sense. And now we need to do the same thing for our exit values. So we're going to do a public float for exit dive duration, and set that at a default of 1, and set up an animation curve for that as well. This will make it far more customizable and quickly iterative for you to work with. Now we're going to set up some private fields. The first thing I want is we're going to set up an int for our dive parameter. If you aren't familiar with utilizing animator.string-to-hash, I highly recommend that you use it. We're going to pass in the string value of that parameter that we have. This is converting it to an integer, and the lookup is much faster for Mecanim to be using that integer value rather than the string value that most people tend to use. And now we're going to set up a float for our dive progress, which is actually just going to be eventually where the animator is currently sitting at is what's going to be reflected in dive progress. But we don't want to do a lot of get float stuff. We'll just store it in the script and call it from there as we need it. So now we're going to store an IEnumerator. And this IEnumerator is going to be a reference to, I'm going to call this the blend that we're actually running. So we'll call this current blend. That's a good name, I think. So every time we run this coroutine, we're going to store it here so that we can stop it and start it as needed. All right, let's go ahead and write that coroutine now, and then we can start handling our input to run it. So I'm going to do our private IEnumerator, and I'll call this dive blend. And we're going to pass a couple things in here. The first is going to be our target weight. And that's going to be either 0 or 1 in this case, but if you do a more advanced system, you can just have at it. And then we're going to need our duration, which in this case we're going to be passing in that enter dive duration or exit dive duration. And then the animation curve that we are going to be evaluating along. And those are also fields. So the first thing we want in here is going to be a float value for the elapsed time that's actually happened. So we'll set that up, and then we're going to do a float for our starting progress. And that's going to be the current dive progress that's stored in our class field. And now we can start out our while loop. So while our elapsed time is less than our duration, we're going to be inside this loop. And the first thing we want to do is start manipulating our dive progress. So our dive progress is going to be equal to mathf.lerp. So we're interpolating between two values here. And we're going to do our start progress and then our target weight. And we're going to be evaluating along this curve. So we're going to call curve.evaluate. And since that's a value between 0 and 1, we're going to pass in the percentage of our duration that's already passed. So we're going to do the elapsed time divided by the duration. That's going to give us a nice value between 0 and 1. And it's going to pull a point along that curve, and that's how it's going to determine how fast or slow it needs to move to the next point. And then we're going to add the time.delta time to keep this thing moving forward. Now that we've got that, we need to set our float in our cam animator, and now we're going to pass in that dive parameter that we stored. So that integer value that refers to a parameter, and we're going to pass into it the value of dive progress. So every frame this is going to be updating that time, or that float parameter, and we'll do our yield so that we can actually get out of this loop eventually. And then at the end of this, because we're using mathf.lerp, on occasion you're not going to totally reach 1, and you're not going to totally reach 0. You're going to be off by a very small fraction. So you might be at 0.9998 when it exits the loop, or you'll be at 0.0001 when it exits the loop. So the first thing that I do when I exit these loops for this is I'm going to set my dive progress to the target weight. So it's always going to end up at 0 or 1, and I'm going to set the value of that float parameter on the controller to that new dive progress. Now we just need to handle all of our caching of this coroutine and our input. On the forums, all the input was done by pressing and releasing the spacebar, so I'm going to do the exact same thing. So we're going to do input.getKeyDown and pass in our key code for space. And the first thing I need to do is check to see if our current blend is null. If it's not null, we need to stop it. So we're going to say stop coroutine current blend. And now we need to assign a new value to the current blend. So right outside of that if statement, we're going to say current blend equals dive blend. And since we're entering the dive, we're going to set our target rate to 1. Our duration is going to be the enter dive duration. And we're going to do the enter dive curve for the curve that we're going to be evaluating. And then we'll kick off that coroutine with start coroutine, current blend. Now we need basically the same code for our lifting of the spacebar. So I'm going to copy this and do some editing, strictly for time. Generally I don't do this, and I just noticed I don't even have an if around here. So we need if input, or in this case we're going to do get key up, and I'm going to change our target weight to 0, and I need to change enter dive duration to exit dive duration, and enter dive curve to exit dive curve. So now, everything that we've got here, when you press down on space, it is going to check to see if we have a current blend running. If we do, stop it, set up a new blend, and start it. Once you release, if there's a blend running, we're going to stop it, set up a new blend, and start that new blend. That's all there is to the entire system as it stands right now. I haven't designed anything more advanced than this for this particular case. So we're going to pop back into Unity, and now we have all of our values available on our dive handler. I'm going to drop our camera in there. The only reason I set that up as a public field is just so if you wanted your handler to be on a different object, you could do that. It's totally your preference. I'm going to set up our enter and exit durations to 2 seconds just so we can have a little bit more to play with. And now we have these curves. So I'll click on our enter dive curve, and I'm going to set this up as a linear, very, very linear interpolation between 0 and 1. Whoops. And so straight line going across there. And if we play, right now I'll hit space, we'll get a nice interpolation down to our target weight and back up to that starting weight. And now we're going to mess with these curves. I'm doing this all in play mode, so none of this is going to persist over. If you do like something and you're in play mode, make sure that you hit that little cog to copy the component and then paste the component values when you go back into editor mode. So, editing these curves, I'm going to start out by taking our enter into dive, and we're going to make this this nice curve that is going to be very slow and then pick up speed towards the target weight. So with that set, if we watch our game view, you'll see we'll go pretty fast at the end of it, and then we're linear back up. So we start out slow, pick up speed, linear on the way back up. Excuse me. And one of the things we can do with this, if you want to super customize your curves, is you can create new keyframes inside of these curves, just like in the animation window. And we can do something pretty wacky on our exit curve. If we put this style of curve, we'll get a nice camera bounce. So now I'll get that nice smooth interpolation going into the dive, and when I come back, it's going to bounce. And if we shorten our duration on our exit, we get that nice dive in and then a very quick bouncy exit. There's a couple different curves that you can set up by default, or you can add your new presets if you want to. Unity allows you to do that as well. So we can just mess with these different curves all day long, find things that work for you, set up your own custom curves. Any way you want to do it, the system is there for you to customize as much as you want. I'll go ahead and package everything up, get the code nicely commented for you, and get this video linked on the forums. So I hope this gets you closer to the solution that you are looking for. If you have any more questions, I'm more than happy to help. Just continue posting on the forums where we started this conversation. Thanks so much for your time.